Number 57 on page 411 is a little different than our previous example, number 51. And the difference is that we're asked to find all the solutions to the equation. We're not asked to have any constraints on our solution, so it's not in a specific interval. So this is going to present another challenge for us because, as we know, our angles can continuously go around and around and around the unit circle. So we have to take that into account. We'll worry about that when we get the solution. So the first thing we want to talk about is that we have a quadratic expression, so to speak, because cosine is squared. So this might be a little hard to deal with for some of these when we have expressions like this that we need to factor. So what I'm going to do is I'm going to introduce something that we're going to use in calculus a lot, which is called a U substitution. So we can replace a trig expression with a algebraic one, and usually the letter that we use is U. And we'll let U equal cosine x. So now what we have is we have a simple algebraic expression that we have to simplify. We have 4u squared minus 4u plus 1. And now we can factor that, and then once we have factors, since it's equal to 0, we'll be able to set our factors equal to 0. Hopefully you recognize that this is a perfect square trinomial, and it is 2u minus 1 squared. That's going to equal 0. So we have that 2u minus 1 equals 0, so u is going to equal 1/2. So what that means in terms of our solution is that cosine x is going to equal 1/2, since that is what u equals. So now we have to think about what values, what angles do we have when the cosine of x is 1/2. Well, that happens at our pi over 3 angles in the first and fourth quadrant. So if we write them this way, we can write it as pi over 3 and negative pi over 3. So if we write it as plus or minus pi over 3, that makes it easier for us to write every other trip around the unit circle. So that's going to happen a whole trip around, or 2 pi. Every 2 pi, we're going to be at pi over 3 or negative pi over 3, depending on which of the two angles we start with. So what we can do is we can say we're going to take 2 n pi trips around the circle, where n is an integer. So we're going to say n belongs to the set of integers. So that's going to be our solution then. We're going to have all the positive pi over 3 angles. Every trip around the circle will end up again, if we start at pi over 3 in the first quadrant. If we add a 2 pi to it, we'll still be at the same angle. And the same for negative pi over 3. If we start from there and we take one whole trip around the circle, which will be at 2 pi, or 4 pi, or 6 pi, 8 pi, we will always end up at negative pi over 3. So this is the set of all the solutions to our original equation.